In this video, we are going to review some techniques for finding the trigonometric integrals using the substitution method. So when trying to compute the integrals containing terms of the form the square root of a squared minus x squared, or the square root of x squared minus a squared, or the square root of x squared plus a squared for some a, we need to make use of some clever substitutions here. And for this type of integrals, it is very often the case that making these substitutions involving a trig function turns out to be very helpful. So let's take a quick look at this example. Find the integral of dx over the square root of x squared minus 2x plus 5. Now if you look at this integral and you try u to be x squared minus 2x plus 5 first, then you can find du equal 2x minus 2 dx, but then we don't have any of the x variable from the numerator, and therefore it is not helpful to try to let u to be the radicand. So you cannot do that method here using the normal substitutions. And now because we see that there is the square root, so think about using the trig substitution of the square root. But looking at these three expressions, you don't see that it is matching to any of the terms here. So first thing is we need to try to completing the square of the integrand inside here. I mean the radicand. So let's try to completing the square. X squared minus 2x plus 5. So I'm trying to completing the square of this term. So when I try to completing the square of this term, I rewrite x squared minus 2x and I plus the constants all the way to the end. Now I take the middle term, which is minus 2, I divide by half and I square that. It gives me minus 1 squared or equal to 1. So I know that I need number 1. So I add 1 and at the same time I subtract 1 because I don't want to change the value of the whole expression. Now this whole trinomial term here turn into x minus 1 square. And then these two become 4. So plus 4. And therefore I can rewrite the integral dx over the square root of x minus 1 square plus 4. And now you see that we have something that is similar to one of the three expressions here. So looking at the last expression, I see that I have something square add to something. So it looks like that I can go ahead and let u to be x minus 1. So I'm trying to make it similar to the last expressions. If I let u to be x minus 1, then I can find du to be dx. And now I can rewrite the expressions as what? Dx now du divided by the square root of x minus 1 square, which is u square, and then plus 4. I want to rewrite 4 as something square so it's matching to the last expressions. So I can write 2 square because 2 square is just 4. And now we know that we can follow the formula here and we let x, in this case x is the expression before you square that, or we let u, because u now is in the place of x, u equal a is the one before square, which is 2, and tangent theta. So now this is the correct substitution that we will need. And then we need to take du. du now, when you take the derivative on the right hand side, tangent tangent theta, when you take the derivative, you get secant square theta. And don't forget number 2 here. And then d theta. And we know that the domain for the integrand is all real number, such that the theta, the angles, is between minus pi over 2 and pi over 2. And that the secant is bigger than 0. And now I can go ahead and make the substitutions of the terms inside the square root here. So therefore, the square root of u squared plus 4 is going to be equal to u squared. U squared is 2 squared tangent square, which is 4, and tangent square, and then plus 4. And I know that I can factor out of 4, give me 1 plus tangent square. Right? When I pull out of 4, I have 1. When I pull out of 4, I have tangent square. And I know that 1 plus tangent square is equal to secant square. Secant square. And when you take the square root of secant square, given the fact that secant is bigger than 0, when you take the square root of secant square, you will get secant. When you take the square root of 4, you get 2, or you will get 2 secant, the absolute value. And that is equal to secant of theta. Okay, now we are ready to make the substitution back to the expression right here. So I have du. Du, remember when you convert everything back to theta, du is equal to 2 secant square theta d theta. And we have the square root of u squared plus 4, and we simplify this whole radical into 2 secant theta. And now we can cancel out number 2 and cancel the power of secant. I only have the integral of secant theta d theta. And the integral of the basic function of secant theta d theta is just the ln of the absolute value of secant theta plus tangent of theta and plus c. And then the last step is I'm trying to rewrite the theta in terms of x. So we have secant of theta and tangent of theta. I know that u equal to tangent of x. Therefore, u equal to tangent of theta. Therefore, tangent of theta equal u divided by 2. But then u is given as x minus 1. So I'm trying to rewrite everything in terms of x. So tangent of theta is equal to x minus 1 over 2. What about secant of theta? Now to find the secant of theta in terms of x, let's use the expression of u equal to tangent of theta. U equal to tangent of theta. And I know that I can solve for theta. Tangent of theta equal u divided by 2. And I can draw the right triangle. This is theta. So remember, tangent is the opposite divided by adjacent. So tangent of theta equal opposite divided by adjacent. And therefore, you can find the hypotenuse, which is the square of these two adding together. So u squared plus 2 squared, and then take the square root. Now, the reason that I want to label the right triangle, because from here, I can find secant of theta. You know that secant is 1 over cosine, okay? And you know cosine is also equal to cosine of theta equal to adjacent divided by hypotenuse, which is 2 divided by the hypotenuse, which is 2 square, u square plus 2 square, which is 4. And 1 divided by that, I can flip the fraction into the square root of u square plus 4 divided by 2. But at the end, I still want everything in terms of x. And I know that I let u to be x minus 1. Okay? Therefore, I can make the substitution here to be x minus 1 square plus 4 minus 2 over 2. And then I can expand this guy out, right? We use the formula a minus b, the whole thing square equal a square minus 2ab plus b square. So we can expand this one using this formula. So I have x squared minus 2ab, 2x plus b squared, which is 1, and plus 4, and then the square root, and then over 2. Or you can rewrite this one as the square root of x squared plus minus 2x and then plus 5 over 2. And now I'm ready to plug in everything in terms of x. So I have ln and secant of theta, which is the whole expression here, the square root of x squared minus 2x plus 5 divided by 2 plus tangent of theta, and tangent of theta is this expression right here in terms of x, x minus 1 divided by 2, and then plus c at the end. So this is the final answer. This is the answer. This is the answer for this original iterations. Okay, thanks for watching.